good evening all. Welcome back. So in this session, so we are about to start module 2. So in module 2, we'll be discussing some important points like how we'll be installing STM32Cube IDE. So this particular IDE we are going to use to program like our host machine and even the target machine. So host machine in the sense like we will be writing the C program for the desktop. So I think most of you are familiar with C programming. So let's revise those concepts, and which is very necessary for embedded programming. So those concepts will be like checking once more. So here this Cube IDE, so this development environment we are using for both for the host machine and for the target. So target, as maybe like I already explained in module 1, we are going to use STM32F4 Nucleo board. So this Nucleo board will be the target, and for the host machine, that is like our x86, so the processor, and we will be writing the program using this Cube IDE. So the Cube IDE is dedicatedly like designed to program STM32 microcontrollers. Like in STM32, you can get plenty of different controllers in this course, but like I told already, we are going to use STM32F411RE. So that is an ARM Cortex based microcontroller. Like I'll be discussing like what is this ARM architecture and what are the other microcontrollers. I think in short, everybody is aware like there are different microcontrollers. It can be 8-bit, 16-bit, 32-bit, 64-bit and all. Right. So this STM32F4, that is ARM Cortex controller, which is a 32-bit microcontroller. So that details I'll be explaining what is the ARM Cortex architecture. Yeah. So in this session, let's see how we are going to like do the procedure, how we'll be installing this IDE. So as usual, you must have like downloaded several IDE, and we'll be like follow certain certain conditions and criteria, and we can install this IDE. So I'll share the link. Maybe for this session, I'll be sharing the link from where you can download the STM32 Cube IDE, the updated version. Before, I'm not sure, before maybe we were using CubeMX. I'm not sure whether somebody already used it. So we will be writing, maybe for programming, we'll be using CubeMX. And after that, we have to use like other compilers and all. So this IDE is giving the guarantee that we can write the program here and we can compile, we can debug. So everything like in one platform. So that's the best idea to use this IDE, and it is open source. You can use it in Windows, Linux, or Mac, whatever your operating system, you can use it. Yeah, so these are some features I thought I will be discussing about this IDE before going to the procedure. All are familiar what is an IDE. We must have used several IDEs for different programming. So now from this official website, so this link, if you are clicking on this link, you will be able to like get this st.com's official website, and from there we can download this Cube IDE. So the latest version we just want to like select. So that thing only have to take care. And apart from that, I would like to discuss certain features of Cube IDE, why we are using Cube IDE and for what purpose we can use Cube IDE. So I listed already certain points here. So Cube IDE is advanced C++ development platform. With peripheral configuration, code generation, code compilation, and debug feature for STM32 microcontroller and microprocessor. As I told already, this is completely dedicated for STM32 microcontroller family. So in that like different controllers you can get. So we'll be able to use this for the STM32 programming. And one more thing I would like to add here, we can use this IDE like either like for C development and C++ program development. Either you can use embedded C as the programming language for the same controller. Or if you want, you can use embedded C++. Certain like nowadays there is a trend, or maybe there is a requirement in the industry, like people would like to upgrade and they would like to use embedded C++ code. So we know, right, C is a procedural oriented programming, and that has several limitations. So this procedure oriented programming as C, like the entire C programming will be based on functions, function definition, and function calling. So based on that structure, we are writing the C program. On the other hand, if you would like to use C++, of course, for the advanced project, you can, the concept of object. We can create object, we can use class. So this all enhancing the coding efficiency, right? We will be able to write some better code. Like in real life, if you are considering anything, we'll consider everything as an object that will be having certain attributes. So that means data also, functions also will be there. So this kind of features and all we can implement on C++. Anyway, like in this course, we are going to do embedded C. So next level you can plan. Once you are comfortable with this controller, later on you can upgrade, okay, or maybe the same program, whatever we have done, okay, whatever device drivers we developed today, so you can upgrade and you can write that in C++. So you'll be able to see the differences. Okay. Yeah, so this ID we can use for both purposes, for programming in embedded C or C++, right? And apart from that, I would like to tell you STM32, this Cube ID is a Eclipse based ID. Okay. And like it's having GCC tool chain development and GDB for debugging. Okay. So GCC compiler and GDB. Okay. So that's for the debugging. So these are the two things which is already there in Cube ID. We don't want to install anything. If you're if you're using this ID for the target machine, we don't want to install any GCC compiler, even it's already there. Okay, even GDB is there for debugging. And it allows integration of the hundreds of existing plugins that can complete the features of the Eclipse ID. So we are getting the complete features of the Eclipse ID. So that all are the benefits. Okay, so all are the features we are just getting with only by installing this ID. Okay. And STM32Cube IDE also includes standard and advanced debugging features, okay, including views of CPU core registers, memories, and peripheral registers, okay. So all these things we will be able to monitor separately. Even if you don't have any like a separate thing, okay, serial monitor or something, even if you don't have, like only using this IDE itself, we'll be able to like verify the status of the registers, okay. So the registers, how it is changing, what's the present value, so all these things we'll be able to check using this Cube ID. In the earlier era, we were not using any IDs and all. So we'll be having certain ID. Okay. So like what we will be doing, we will be installing the compiler, debugger, everything separately. Okay. So that was the tedious task. And right now we don't need this advanced or modern IDs and all, having everything inbuilt. Okay. Compiler and debugger as we discussed already. Okay. So we can immediately, once the code is tested, we can immediately create the hex file and we can download that to the target board. Yeah, again, I'm stressing this ID is completely dedicated for the target machine, which is any STM32 microcontroller. Alright, so now you can see this is what the target board which we are going to use in this course. Okay, so the link I can share it in the description. You can purchase it and all the experiment. Okay, whatever we planned in this course, like I'll be doing based on this Nucleo board. Okay, so it's very easy to get and like a simple one. Okay, it may cost you a few dollars. That's it. Then you can implement all the all the different peripherals. Okay, all the project you can implement with the help of this ID. This development board itself contains certain things like few LEDs are there, push buttons are there. So the basic programs and all you will be able to test all like without any other peripherals. Only with the help of this Nucleo board you can test it. I think some of you already used like Arduino board. Okay, so in Arduino board, you know, like there are certain LEDs and push buttons. Okay, so I think there is no sensor, but here we have a temperature sensor inbuilt. So a little bit inbuilt features are there. That's a bit like that's the reason we are preferring any Nucleo board or like any other discovery board or something for the development. Okay, so even if you are not comfortable or if you are not aware how to connect the external hardwares and all, just to test the initial projects and all, this Nucleo board itself is sufficient. If you want to get more like more space or more competence, if you want to add, even you can go for discovery board, right? So this is the simplest version. As a beginner level program, maybe for this course, we will prefer Nucleo board, right? Yeah, so this is about the target board and I would like to talk about the host machine. I told already this Cube ID we are going to like use for the target programming, target machine programming and also for the host machine programming. For the target machine programming, of course, you should know about embedded C and even you should know about the microcontroller. Okay, so you should understand the microcontroller like anatomy. Okay, from top to bottom, you should know what are the different registers. Okay, what are the different peripherals, how I'll be configuring. So all this information you should know. Okay, then only you will be able to program the target machine. Okay, but just to program the host machine, okay, we just want to know the C programming. Okay, so simple C programming, at least all are familiar, right? At least how you are taking input from the user. Okay, so like the simple printf and scanf function and all, using that we can create some application. In the higher level, we will go and we will discuss about loops, functions, okay, and pointers and structures, union. Okay, so all these things. We'll start with the primitive data type, then we'll move on to the user defined data type, and based on that we can create like a lot of interesting application. So this kind of programs I would like to test for the host machine. Okay, so the host can be different because somebody is using a Linux system, Mac system, commonly like people are using Windows system. Maybe as a beginner, Like I'll show all this experiment, that means all this procedure we'll be doing for the Windows machine. And for Linux and all, it will be more easy. Okay. So for Windows host machine, if you are doing the program, okay, listen carefully. Yeah, for the Windows host machine, if you are doing the programming, we have to do some extra settings. Okay, so that may be confusing you. I'm telling not for the target machine. For the target machine, we don't need any extra setting. Everything is compiler, debugger, code generation, everything is inbuilt in this Cube ID. So what I am thinking that even to write the program, even to write the basic C program, I would like to use this Cube ID, this STM32Cube ID itself for the host machine. The reason is that I thought maybe at least you will be familiar with this IDE. Okay. So initially we are anyway going to discuss about C programming. So at least try to write the program, debug. Okay. So compile everything you do in this IDE only. Okay. And I am telling I am using Windows system. Okay. So for Windows system, if you are using Windows system, we would like to install the GCC compiler separately. So that is only one thing we have to take care. So that procedure anyway I'm going to explain. Right. So GCC compiler we will be installing separately. We will be using MinGW. I'm not sure, maybe somebody already installed this, okay, with some other IDs and all. So here I'll show the complete procedure how you can install MinGW. Why that is required? We require that just to program the host machine. Okay, if you want to simple C program for the host machine, if you want to write, you have to compile, right? Okay, without compilation, what's the necessity of writing program? Okay, so we'll be compiling. If you want to compile, we need a GCC compiler. So MinGW is a GCC compiler for the Windows machine. So we'll be installing that separately. Yeah, so that's little process we will do. And for Linux and all, we don't want to. It's already GCC is a part of it, so we just want to run certain commands in the terminal. That's enough. Okay, but Windows the procedure is little not difficult. Okay, but we have to like look at that procedure, right? And yeah, so that is about the host operating system. And I'm just telling again and again, host operating system is Windows here in my case. And the host, okay, host means the x86 microprocessor. Okay, so maybe the, like you can imagine the system, whatever we are using, laptop or desktop, whatever it is. For that machine processor, for that processor, we are writing the program. Okay, so that is one thing. I hope it's clear why we are using CubeID and what we will do for the target machine and what we will do for the host machine. Now I would like to introduce one more term here, cross compiler. What is cross compiler and why we need cross compiler? Okay, so then we will be like discussing almost all topics on IDE. Okay, so what is this cross compiler and why this cross compilation is required? As I already told you, first I will write the program for the host machine. So what is your host machine? You can see here it is the x86 host machine. Okay, x86 machine, which is our desktop. Okay, suppose. And but the program, whatever we are writing, for what we are writing, we are actually writing the program for the target board, right? So the target board can be like STM32 Nucleo board, which I showed you, or any other target board, like any 16-bit or any 8-bit. Okay, Arduino, right, or maybe 8051 or PIC, okay, whatever it is, the target board or the target microcontroller. So we know, like, we are not writing the program like in the target machine, right? In the target machine, you can see it's a simple Nucleo board. In Nucleo board, how you will be writing program, where you will be typing the code, where you will be writing the program. We don't have any option. So usually, as embedded engineer, what we will do, we will be writing the program for the target machine, but we will be writing that in the host machine. Okay. That means within the system, we will just open this ID, which we are about to install now. We will be opening that ID. We will be writing the C program or embedded C program, especially embedded C program. I am writing it's like typically for the target machine. Okay, C program you will write only for the host machine. Okay, so that you are just testing to learn C programming. Okay, so that is you are writing for the host machine and you are even compiling that for the host machine. For that I told you have to use MinGW. We are writing the program in the host machine. Okay, for the target board. Target board is a Nucleo board. Okay, which is having ARM Cortex microcontroller. So in host machine we know we are having x86 machine where we are writing embedded C program for the target board. The target board is an ARM based microcontroller. Okay, ARM Cortex microcontroller. So we should use cross compiler for compilation. Okay, why? Because both are different, like a different environment, right? x86 microcontroller or microprocessor, which is the host machine, and the ARM Cortex microcontroller, which is STM32F411RE. Okay, so both are entirely different. Okay, so we will be writing the program for the target board in the host machine. Okay, so for this compilation, we need a cross compiler, right? If you are using the cross compiler, then only you will be writing the program. We will be writing the program, we will be compile it, we will generate a hex code. Okay, everything we are doing for the x86 machine. Okay, but before doing that, we will be selecting the target board is whatever. Okay, if it is ARM machine, we'll be selecting that. Accordingly, it will be generating the code. Are you clear? So this is one concept. So here we don't need compiler, we need the cross compiler. Why? Both are different environment. That's it. Okay. So that is one additional term I thought we'll discuss. Anyway, Cube IDE is already having cross compiler. So we don't want to install anything separately if you are writing the program for the target machine. So now these are certain points about a cross compiler. A compiler capable of creating executable code for a platform other than the one which is where the compiler is running. I already told you there are separate platforms. So okay, so in that cases we need cross compiler. It's a fundamental use is that separating the build environment from the target environment. Okay, so anyway, in the target environment we can't write the program. I think that I already cleared. Okay, you don't have any display. Okay, so where you will be looking the program, whatever you are writing for the Nucleo board. Okay, so where you will be seeing that you don't have any option. Of course, you can use LCD and some other displays and all later on, but maybe that also not very efficient. So we'll be writing the program for the host machine only. Okay, program in the host machine for the target machine. Okay, embedded system, that means this kind of microcontrollers and all, they will be having very limited resources. Okay, it is not even powerful to run a compiler, okay, or a developing environment like in the embedded system devices. That is dedicated only for certain application. That's it. Okay, they are not dedicated for programming. Of course, programming will be done, but through the other device. Okay, a single build environment can be set up to compile different targets and all. Right. So one example I will tell you, pacemakers. Okay, so that we are actually using inside the human body. So we can't directly interact and we can't directly write the program. We'll be connecting that to any host machine. Then once we'll program that code, we'll be dumping to the pacemaker and we will be implementing like that wherever it is using. Okay. So till the battery. Okay, so battery will be supplying the power. Till the battery supplies the pacemakers will be working as per the written program. Okay. So like that embedded application, as you know, it is written only for a specific application, right? And even it's not even decided or designed just to use any IDs on the with embedded system. Yeah. So in this session, in the first lesson of module 2, we were discussing about what is STM32Cube IDE. Okay, I haven't showed the procedure how we'll be installing, but I was just telling what is this Cube IDE. Okay. So in this IDE, like as we discussed, we have compiler, debugger, everything inbuilt. Okay, so you don't want to install anything separately for the target machine, but for the host machines, if I am using Windows, I have to install the GCC compiler separately. For that, we'll be installing WinGW. So these are the two major takeaways from this lesson. And after that, I was discussing about the cross compiler. I think cross compiler also clear, right? For embedded devices and all, they are not even designed to write some programs and all. Okay, we can't use any IDs and debuggers with embedded devices. So we'll be writing the program in the host machine, and then after that we'll be transferring that to the target machine. Okay. So for that we need a compiler. That's a special kind of compiler which is known as cross compiler. So these are the two things, or maybe these are the major things which we discussed already in this session. Okay. Yeah, so thank you all. We will we'll continue, or we'll see in the next lesson. So in the next lesson, I will be introducing, or I'll be showing what is the actual procedure to install Cube IDE. Okay, so till then, bye bye.